This is just a continuation from the last video. In the last video we had discussed what a rate of change is, and we also identified why the slope represents a rate of change. So we still have to look at a couple of examples. So we're going to do that right now. Actually, before we take a look at the two examples, quick definition of what a secant line is versus what a tangent line is. So with a secant line, I'm just going to draw a function right now. We'll call this one f. The word secant comes from, I think it means to cut or to cut through. So a secant line intersects a curve in two spots. Okay, so for instance, let's just say that line, because it touches the curve in two spots, that would be our secant line. On the other hand, tangent just touches the curve. So if I'm talking about, and it only touches at one point, okay, it does not intersect the curve. Technically, I guess it does. Intersect means point in common, but this tangent line is just going to touch the curve. It just nicks it right there at one point. That is your tangent line. If you want more of an explanation, you can see your book. This is from the James Stewart book, edition 7E. It's in section 1.4. And if you take a look at pages right at the bottom of page 44 and maybe about reading halfway through the page 45, that'll get you a good idea as well. Okay, on to the examples here. First example we're taking out of the book I just mentioned. It's on, the problem set is on page 49. We're going to be looking at question number 2. It has to do with a cardiac patient, I believe. So I'm not going to do the entire problem here. There are, I guess, 4 parts to it. We're just going to take a look at C and D. Okay, so the directions ask us to find the slope of the secant line between the points time 40 and time 42. Okay, so we know the slope is the change in y over the change in x. So in this this table here, it doesn't have x and y, but it does have time, which is usually x, and y for heartbeats. So between these 2 points right here, I'm going to take the change in y, which is 2948 minus 2806, over the change in x, which is 42 minus 40. And just to punch in the top part of my calculator, I guess I can do the denominator of that just fine. So we're looking at 142 over 2, which is 71. And here it's because units are in our problem, we're going to leave our answer with units. And the y values are on top, so that's heartbeats per minute. So that secant line, which represents the average rate of change, has a slope of 71 heartbeats per minute. The other one we're going to take a look at is D, which compares time 42 and time 44. So these two this time. So same thing, we're going to take the change in y over the change in x and this time we're getting 132 over 2, which we're then going to write as 66 heartbeats per minute. Okay, there's another part of this. It says, what are your conclusions? And in the problem, if you read it, it says, use the data to estimate the patient's heart rate right at 42. So we could say, well, there were 71 heartbeats per minute between these two and 66 heartbeats per minute between these two. So if we average those two, we could probably, our conclusions could say we could estimate at 42 minutes that there are about 68.5 heartbeats per minute taking place there. So there's our first example.